Hey, advanced math students, let's go ahead and review and prepare for the test that you're going to be taking here over our lessons from 71, 72, 75, and 78 on test 11. In your packet, you should have received the review list, so if you make sure you have that out for me, you can go and take your notes right on there. Remember, I do not need that review list back. That's for you to keep, and that's for you to study and prepare from for our test that we're going to be taking here. So let's go ahead and start off out of lesson 71. This is where we talked about our ellipse. Remember, the ellipse was the shape that was the oval, and we had to decide, was the oval either going wider along the x-axis or going wider along the y-axis. The first two questions that you're going to be doing for me on the test, I already gave you the ellipse in the proper work format. You had to go ahead and just graph our question. Okay, so if I look at x squared over 4 plus y squared over 16 is equal to 1. Remember when we looked at our ellipse to know whether it opened going horizontally or whether it opened going vertically, you had to decide where was the bigger number. Well, clearly, underneath the y is the bigger number, the 16. That means this ellipse is going to go wider along the y-axis than along the x-axis. We had looked at the letters A and B. The A corresponded with the major axis, which was the longer of the two axes, and the B went with the minor axis. So with the 16, what number did we square to get a 16? It was 4, so my A would be 4. The B corresponds with the smaller number. What did I square to get to the number 4 that was underneath the x squared? It was the 2. So how did we correctly use these numbers? Along the y-axis, because that was the major axis, we went 4 spaces up and 4 spaces down. Along the x-axis, because that was the minor axis, we went 2 to the right and 2 to the left, and then we connected them, and there was the ellipse that you would draw for your final answer for something like questions 1 and 2. Just to make sure we got the idea, let's go through one more question together. So x squared over 25 plus y squared over 9 is equal to 1. Once again, the question's in your proper standard format, so you can go ahead and graph right away. Where is the bigger number? This time it's underneath the x. That means this ellipse will be wider in the x direction and shorter in the y direction. The A always corresponds with the major axis, which is the bigger of your two numbers. So what did I square this time to get to a 25? It was the number 5. What did I square to get to the number 9? It was 3. So the A would be 5 and B would be 3. The x-axis was the major axis, so the bigger number is on the x. I went 5 to the right and 5 to the left. The B is the minor axis, which corresponds to y this time. So I went 3 up and 3 down, and that would be the picture that you would sketch out for me for the ellipse that you would draw for something like questions 1 and 2. Now, on questions 3 and 4, what you're going to have to do first, so this will be like question 3, is going to say to write the ellipse in standard format first. Then on question 4, you're going to graph the ellipse like we just did from questions 1 and 2. Well, how did I get the ellipse into proper standard format? There were fractions on the left-hand side, and the question was equal to 1. Well, how do I get fractions and make this equal to 1? I'm going to divide every single part of the question by the constant on the right-hand side, the 144. So 16 over 144, that reduced down for me to 1 over 9. So I have x squared over 9. And then there's the plus sign, which we had to have for the ellipse. 9 over 144 reduces to 1 over 16. So y squared over 16, and now it's equal to 1. So that's what you do on question number 3. You're going to take an equation that's given to you and put it in the proper standard format. You got the fractions on the left-hand side again, and you have it equal to 1. Now that your question is in that standard format, on question 4, you're going to graph. Well, which direction is the major axis? Once again, it's going to be the y because the bigger number is under the y. How many spaces do I move in the y direction? It would be 4 because 4 squared gave me 16. How many spaces do I move in the x direction? It would be 3 because 3 squared gave me the 9 that was underneath the x. So 4 up, 4 down, 3 right, 3 left, and here's the ellipse that I would sketch out for something like question 4. So that wraps up lesson 71, where we learned about our ellipse. Now, questions 5 through 10, you can see on your review list, is from the law of sines, and that was from lesson 72. These questions will be broken up into sections of 3. So questions 5 to 7 are going to go together, and then questions 8 through 10 are going to go together as well. And let's walk through an example like each one of those questions. So this first problem would represent what you would see on questions 5 through 7. Now, just like I'm going to review it up here on the screen, the same order is going to appear on the test for how you want to correctly answer the question. So just follow the order that I'm going to give you on your test paper, and you should be able to arrive at the correct answer. Notice in the triangle that you see up here on the screen, we have 2 angles and you have 1 side. When we did these questions before, the best way that I like to approach the questions is to find the one part that I'm missing. Well, which piece was just missing one of them? It was the angle. So the first thing I'm going to have you find, this will be on question 5, is the missing angle, which is C. How do I find a missing angle in a triangle? I subtract from 180 degrees. So I did 180 minus the 2 that were already given to me. And like we talked about before, you could add those together first, 48 and 35, and then subtract. I just showed the subtraction twice on my question. So that tells me that angle C is 97 degrees. Okay, so if you want to, you can go ahead and put it in your picture, just like I have up here on the screen. The next thing I'm going to have you answer is side B. Well, in order to answer side B, we had to use our law of sines, matching up the angle to its corresponding side, the pieces that were opposite each other. In order to use the law of sines, we had to have the complete ratio, which we had in this picture, because we had the angle of 48 degrees and we had the side that was opposite, the number 4. So if I'm going to solve for side B, well, which angle corresponds with B? What's opposite from it? The 35. So I said sine 35 over side B is equal to sine 48 over 4, the complete ratio. When 2 fractions were equal, we cross multiplied. So I had B sine 48 is equal to 4 sine 35. Just like we did during class, don't touch your calculator till the very final step, because we don't want to round too early and get too far away from the correct final answer. To get side B all by itself, we need to get rid of this sine 48, so divide it over, and B is equal to 4 sine 35 divided by sine 48, and that gave me 3.09 when I typed that onto my calculator. So as you're practicing, if you're not getting these answers, your calculator's in the wrong mode, so contact me and I'll try to help you switch it back to the right mode so you can do your test questions correctly. We have one more thing to find out of this picture, and it's side C. So how do I correctly find side C? Again, I'm going to have to use the law of sines. Can't use the Pythagorean theorem because we don't have a right triangle on these pictures. Well, what angle corresponds with side C? That was what we found back on question 5. That was the 97 degrees. So I said sine 97 over side C, and there again was the one complete ratio that was already given to us in the question, sine 48 over the side of 4. Cross multiply, C sine 48 equals 4 sine 97. Divide over your sine 48, just like we did on the letter B question, and that gave me that C was 5.34 in our question. So that would be like questions 5 through 7. You'll find the one missing angle first, and then you'll find the 2 missing sides using your law of sines. Now, questions 8 through 10, and this will be the last thing that we'll review for this part of our review lesson, the triangle will look like this. You have one angle and you have 2 sides. So that means I need to find one missing side and I need to find 2 missing angles in this question. Now, these questions, I couldn't do it like I just mentioned, where I always like to find the one thing that's missing first, because I have to use what's in this picture. So what was the first thing that we had to find according to this picture? It was our angle B. Why did we have to do angle B first? Because we had the side that was opposite from it, and we already had one complete ratio. There's nothing that I know about the lengths of either the length of little c or the angle capital C, so I can't start with either one of those pieces. Well, if I am going to look for angle B, I have to use my law of sines. I can't subtract from 180 because I only have one of the angles in the picture. So setting up my angle over its corresponding side. So sine b over its side of 25, and here's our complete ratio, sine 46 over 47. Cross multiply, just like we did on the last couple examples, 47 sine b equals 25 sine 46. To start getting the b by itself, there's going to be two steps that we had to do. The first thing was to get rid of the 47, so we divided the 47 over. Again, we haven't touched our calculator yet because we do not want to round on these questions. So sine b is equal to 25 sine 46 divided by that 47. The last thing that we had to do to get the b by itself was we had to cancel the sine, so we had to do our sine inverse. So the sine inverse of that gigantic fraction, and when I typed that in, I came up with 22.5 degrees on my calculator. Now at this point, you might want to, just like I have up here on the screen as well, I filled in that 22.5 degrees in my picture. Why might that be helpful? Because now on question 9, I'm going to ask you to find angle C. How do I correctly find angle C? Well, you know how to do that because that's the one missing angle and you already have two of them. So we're going to subtract from 180 degrees. 180 minus 46 minus 22.5 gave me 111.5 degrees for angle C in our problem. Now, just to stop here for a second, remember when we did these questions before, we had something that was called the ambiguous case that could give us two possible answers. If I go back to the previous answer, which gave me the 22.5, remember that was the definite answer because that fell in quadrant number 1. Well, the other answer would be in quadrant number 2. So we had to take 180 minus our definite answer, and that for this question gave me 157.5. Well, can I use a 157.5 on this question? We can't, because we already have a 46 in the picture. And if I add 157.5 with the 46, I get 203.5, and I've exceeded the limit for a triangle. So the question that you're going to do for me on the test, there is only one set of answers like I'm showing you here on our slide. It is not going to be the ambiguous case that you're going to have to work through with two sets of answers for each question. All right, so finishing up our problem. We now have angle C because we subtracted from our 180 degrees, so I'm going to go ahead and fill that into the picture. The last thing that we need to find is the side of C. How do I find the side of C? We're going to use our law of sines once again. Remember, the one complete ratio was the angle of 46 and the given side of 47. So I'm going to say the sine of 111.5 over side C. There's the pair that we have, the angle in its opposite side. And there's our complete ratio, sine 46 over 47. We know cross multiply, so C sine 46 equals 47 sine 111.5. To get the C by itself, I'm dividing over that sine 46, and that gave me that C was 60.79 in our question. All right, so the next time in our review, we'll pick up on questions 11 and go down through 20 so you can see the second things that we'll need to know for our upcoming test.